Now, some of you found it very suspicious when discussing the Laplace equation in a square on page 41 of the notes. You didn't quite understand how we obtained the fact that bk was equal to naught in some cases. So just to recap, if you go back to your notes on page 41, when we use the boundary condition u of x pi equals to 1, we arrive at the sum of bk sine kx sinh k pi equals to 1. Okay, let me just call this equation number 1. And from the Fourier sine series for f of x equals to 1, Fourier sine series for f of x equals to 1, we arrive at the conclusion that the sum of 4 over k pi sine kx is equal to 1, but this was only valid for odd numbers. And so it was not clear how come the bk was equal to 0 for just for even numbers. Now, to make this clear, obviously we're going to be doing a comparison here. So if you look quite closely, you'll see that both these expressions have got a sine kx. Both expressions have got a sine kx, and we need to make a comparison involving the bk sine k pi. Okay? Now, if we write that equation 1 as sigma bk sine kx sinh k pi plus sigma 0 sine kx sine sinh k pi equals to 1, then you can appreciate immediately, of course, that this part here applies, this part applies when k is equal to an odd number, and this part when k equals an even number. Now you can see by a direct comparison that when k is even, right, you find that the comparison is with this part here, and obviously that must be a naught because we're getting a 1 on both sides. So it follows that when k equals to odd, the bk must be the same as 4 over k pi, rather the bk sinh k pi is 4 over k pi. On the other hand, when k is even, you can see the bk sinh k pi must be equal to naught by a direct comparison between these two. You see, after all, we're comparing the bk with this part here. So the bk, the green parts, are the same in both cases.